This video is going to be a very quick video on simplifying rational expressions, including multiplication and division. So step one is always factor. So actually let me kind of outline steps. Step one is to always factor. Step two is to state your restrictions of your domain. Step three is to simplify. And then step four is to label your restrictions. So like call them removable or non-removable. Okay, so let's go back to the very first problem. And our first step is to factor it. Well, this really can't be factored. I mean, you can break it up into x times x times x and y times y if you want to, but hopefully you don't have to do that. So the next thing we're going to do is label our restrictions. Well, x, let's do that in a different color. X cannot equal 0, and y cannot equal 0. Because if x were 0, 0 squared is 0, and 0 times 6 and y cubed would be 0, and that would be not good. Same with y. So we've factored it, we've stated our restrictions, now we simplify. 24 over negative 6 simplifies to just negative 4. X cubed over x squared simplifies to just x, and y squared over y cubed simplifies to just y in the bottom of a fraction. If you don't remember how to do the simplification, you need to check out a video on exponent rules. You subtract exponents when you divide. When you have a negative exponent, it relocates to its reciprocal location, its inverse location. But anyways, with this video, here's our answer. Negative 4x over y. The last step we have to do is name our two restrictions as removable or non-removable. Well, if you notice, the y didn't go anywhere. Yeah, we simplified it, but my y can't equal 0, it stayed there. So it's non-removable. That's terrible writing. I'm just going to write NR for non-removable. And my x value did move. It is gone. It's been removed. So our x can't equal 0 is removable. Alright, let's try it again. With this problem over here, step one is to factor. What multiplies to get negative 8 and adds to get positive 2? X plus 4 and x minus 2. What multiplies to get 6 and adds to get negative 5? X minus 3 and x minus 2. So step one is done. I have factored. Now I set my restrictions. X cannot be 3. X cannot be 2. Because 3 minus 3 is 0, and that'll create a 0 in the denominator. Same with the 2. So now we move on to the next step, which is simplify. X minus 2 over x minus 2 cancels out, meaning we're left with x plus 4 over x minus 3. Now we just have to label our zeros, or our restrictions rather. The x can't equal 2, that was removed, so it's a removable 0, whereas my x can't equal 3 remained, so it's non-removable. Alright, so hopefully you get that concept, because it's really the same concept with just a few changes as you multiply and divide. So we have two rational functions being multiplied by each other, or two rational expressions being multiplied by each other. So the first thing we're going to do doesn't really change. We're going to factor everything. So I've got x plus 3 and x minus 2. Here, let's go below because I'm going to run out of space. So we got x plus 3, x minus 2 over x minus 5 multiplied by x plus 5, x minus 5 over x plus 3, x plus 1. So those are the factored, and again, if you're having a hard time factoring, you need to watch a factoring video. I'm not going to explicitly go over how to factor simple a values of 1 quadratics. So now we move on to stating our restrictions. X cannot equal 5, x cannot equal negative 3, and x cannot equal negative 1, because at any of those points it could give us 0, and when we multiply by 0 we get 0, so that will create a problem. So now we simplify where we can. X minus 5 over x minus 5, and we can do that because it's multiplication. If it were addition or subtraction, we wouldn't be able to simplify that way by crossing out. But really, we could rewrite this as one big long fraction. They don't have to have common denominators. So I can eliminate the x minus 5s. I can also eliminate the x plus 3s. And so really, I'm left with x minus 2 times x plus 5 over x plus 1. So when I do that, I will get x squared plus 3x minus 10 over x plus 1. That is my simplified answer when I redistribute my numerator. And now all that's left is I have to label my restrictions. So everything was removed from the denominator except x plus 1. So this one's non-removable. The other two are removable because they were removed. And so non-removable gives me an asymptote, a vertical asymptote, where removable gives me a whole. Alright, so that's multiplication. One last problem, and it's division. Division, you do exactly like multiplication. There's just one little step in there. After you factor and after you state your restrictions, you must flip your divisor. So whatever comes after the division symbol, you must make it the reciprocal. So you just flip it. Then you have to find the restrictions of the new denominator, and then you can simplify and label your restrictions. So let's show you what that means. First, we have to factor everything. Now, I will show us how to factor these types of quadratics. So first, I'm going to pull out a greatest common factor of 2. That leaves me with 5x squared minus 14x plus 8. And a 2 here leaves me with x minus 2 divided by. None of those factors have greatest common factor, so I'm going to go ahead and step to the AC method. So 25 times 4 is 100. I'm looking for two numbers that multiply to give me 100 and add to give me negative 25. Well, I know that that is negative 20 and negative 5. So I rewrite my expression. 25x squared minus 20x minus 5x plus 4. So I've rewritten my expression, but I've changed negative 25x to negative 20x minus 5x. Let me rewrite it a little better. And now I group. These two have a 5x in common. That leaves me with 5x minus 4. These have a negative 1 in common. That leaves me with a 5x minus 4. Now in this big long expression, they have a 5x minus 4 in common, and that leaves me with a 5x minus 1. So those are my factors. Let's work again here. So moving on to the denominator, what multiplies to give me 40 and adds to give me negative 41? Well, that's going to be negative 40 and negative 1. So I rewrite my expression and I group. These have a 5x in common with an x minus 8. These have a negative 1 in common with an x minus 8. This big long expression has an x minus 8 in common, leaving me with a 5x minus 1. Almost done. I've got one more to factor. I have to factor this numerator up here. What multiplies to give me 40 and adds to give me negative 14? Well, that's going to be negative 10 and negative 4. And then when I group, they have a 5x in common, leaves me with x minus 2. These have a negative 2 in common, leaves me with an x minus 2. That big long expression has a x minus 2 in common, and that leaves me with a 5x minus 2. Okay, so if factoring is not your strong suit, you're going to need to review how to factor. I did my best to kind of show you the AC method and how to do grouping, but I can't spend a whole lot more time factoring as this is a rational expression video. So the next step is to state my restrictions. So x can't be 2, x can't be 8, and x can't be 1/5. And that's because if I set all of my factors in the denominators equal to 0 and solve, I'll get 2, 8, and 1/5. So now, with division, I'm going to rewrite this expression. I got to keep these zeros in mind, and I've got to flip my divisor. So this one, I need to flip the order. So I'm going to rewrite that to x minus 2, 5x minus 2. Oops. I'm sorry. That's not right. Someone should have stopped me. 5x minus 4. These down here have a negative 4 in common. Alright, doesn't change much. I just changed that one little factor. So I rewrite this as 5x minus 4 over 2x minus 2. And now I'm going to change it to multiplication, but flip my fraction. 5x minus 1 over 5x minus 4 times 5x minus 1. Alright, so I'm going to take this to the next page. I'm going to rewrite my new multiplication problem and bring over my zeros or my restrictions, and we'll continue on. So let me move on to the next slide so we can have fresh space. So we had 2, 5x minus 4, x minus 2 over 2x minus 2 times 5x minus 1, 5x minus 4 over 5x minus 1, x minus 8, and we had the zeros that x couldn't equal 2, x couldn't equal 8, x couldn't equal 1/5. And then I had flipped this to get my reciprocal to where I had 5x minus 1 and x minus 8 on the top, and 5x minus 1 and 5x minus 4 on the bottom. So now the only other thing I have to do is state any new restriction I have. Well, I have now x can't equal 4/5. That's my new restriction. Now I'm ready to simplify. 2 over 2 cancels out. 5x minus 1 over 5x minus 1 cancels out, meaning my 1/5 is removable. X minus 2 over x minus 2 cancels out, meaning my x can't equal 2 is removable. And 5x minus 4 over 5x minus 4 cancels out, meaning my 4/5 is removable. And so all I'm left with is a lonely little x minus 8 as an answer, and that is non-removable. So x can't be 8. So that is our answer. X minus 8 is the simplification of that long, crazy division problem. So if you have any questions, please leave a comment. Thank you.